Imagine wanting to buy a car, but instead of walking onto a lot and driving away, you're sent to a massive, chaotic warehouse where your car is scattered into individual parts. The chassis is in aisle 3, the engine is in aisle 10, and the steering wheel is somewhere near the loading dock. This is exactly how traditional relational databases store the information for a user profile. They organize data into strict, separate tables. Login credentials live in one table, order history lives in another, and shipping addresses somewhere else entirely. To put that profile together, the database has to execute something called a join. A join is a command that forces the system to run across the entire warehouse, locate each individual piece of data, and stitch them all together right there on the spot. Keeping data separated in perfectly neat filing cabinets works well for highly structured accounting systems. But when a modern web application has to sprint through the warehouse and assemble these scattered pieces millions of times every single second, that highly organized system creates a massive traffic jam. This raises a practical question. If we know exactly what the final product is supposed to look like, why are we storing it as disassembled pieces? MongoDB was built to answer that exact question. Instead of operating like a warehouse of scattered parts, it functions like a massive parking garage for fully assembled cars. By abandoning the traditional warehouse blueprint, developers can retrieve the exact information they need instantly. Storing data as complete, ready-to-use units drastically accelerates how fast an application can serve information to its users. Under the hood, MongoDB is a document-oriented NoSQL database. NoSQL refers to a class of database systems that skip the traditional table-based relational structure. Instead of cramming data into rigid rows and columns, MongoDB stores information in digital documents that look incredibly similar to JSON. JSON, or JavaScript Object Notation, is a standard text format used to represent structured data based on simple key-value pairs. Let's look at this animated diagram showing how the data takes shape. Instead of scattering a user profile across different tables, we are sliding those tables together into one cohesive file. A user's name, their height, their past orders, and even the comments they've left on videos are all nested securely inside a single digital document. Because this profile is already fully assembled, the database requires absolutely zero join operations to serve it up. When the application requests the user profile, the database just grabs the single glowing file and hands it over. Software engineers call this mechanic data locality. Data locality simply means that related pieces of information are physically grouped together on the server's actual hard drive. By keeping related data physically adjacent, the hard drive doesn't have to spin around hunting for separate pieces. Retrieval transforms from an exhausting scavenger hunt into a near-instantaneous handoff, drastically improving the speed of the application. Traditional SQL databases operate on a strict, unbending blueprint known as a schema. A schema is a formal set of rules that dictates exactly what kind of data can be entered into the database and how it must be formatted. This strictness creates a headache when an application needs to grow. If you want to add a single new feature, like tracking a user's favorite movies, you often have to shut down the system and run a massive, risky database migration just to update that blueprint across millions of rows.
Here, we can see MongoDB's flexibility in action. It is schemaless. This means developers can reshape data on the fly. If you want to track a user's favorite movies, you just pop a new data line into their specific document. The left document expands to hold the new information, while the right document remains completely undisturbed and fully functional without it. This flexibility gives developers incredible peace of mind. You can rapidly add new features and evolve your application over time, without the constant fear that tweaking one table will break the entire system. All this speed and flexibility sounds great, but it leads us to a critical question. What happens when your application experiences explosive growth and your single server simply runs out of hard drive space? Splitting a traditional relational database across multiple servers is a famously difficult engineering problem. Because the data is scattered across tables, those tables are deeply tangled together. If you separate them onto different machines, those complex join operations become incredibly slow over a network connection. But in MongoDB, the documents are entirely self-contained. A user profile document has zero dependency on the document sitting next to it. This independence allows MongoDB to use a technique called sharding. Sharding is the process of distributing data across multiple separate machines. When one server fills up, MongoDB can effortlessly slice the collection in half. Watch how these blocks smoothly flow over to an empty, newly connected server without breaking any internal links. Because sharding enables near-infinite horizontal scaling, you can keep adding servers to handle as much traffic as you need. This is actually where the name comes from. Mongo is short for humongous workloads. MongoDB is a piece of engineering, not magic. Getting these massive gains in speed and scale requires a specific structural compromise. That compromise is data duplication, a concept engineers call denormalization. To keep every single document fully assembled, you might have to copy the exact same piece of information across hundreds of different documents. Operationally, this creates extra work when things change. If a user updates their username, the database can't just change that name in one central location. It has to carefully hunt down and update that name in every single duplicated document where it appears. Choosing MongoDB means you are intentionally sacrificing rigid, centralized data consistency. In exchange, you get blistering read speeds and the ultimate flexibility to build things quickly. Ultimately, MongoDB sits directly in the middle ground of modern software engineering, acting as a highly versatile tool that balances structure with agility. Its greatest utility is that it removes the translation barrier between your programming language and your storage. Developers can just take the data exactly as it looks in their code and dump it straight into the database. Because at the end of the day, the goal of software development is getting the fully assembled car out onto the road for your users, not managing a vast warehouse of scattered parts. If you want to spend time actually building your application rather than endlessly assembling data from scratch, the document model is incredibly hard to beat. If you found this breakdown helpful, hit the like button, subscribe for more deep dives, and let us know what technology you want to see explained next.